from chapter 7.1, and then we'll move on to 7.2, which is, I believe, the addition and subtraction rules. A lot of the chapter 7, at least at the beginning, deals with algebra of trig, right? Manipulating them, turning them from one version of itself into something that's identical, but hopefully nicer, and identities is part of that process. I can't find my original, so I'm just going to write down properties as we come across them. These three here are actually, if you use the top one, you can make the other two harm. You know, so if you remember that cos squared plus sine squared plus cos squared is 1, if you subtract a cos squared from both sides, you get this. And if you subtract sine squared from both sides, you get this. I'll put these three in because I know I'm about to use it for this question. A secant can be replaced by a 1 over sine. A cosecant, I've just put that the wrong way around, didn't I? A secant is 1 over a cosine. Cosecant is 1 over a sine. And a cotangent is 1 over a tangent. That's not that worthwhile, but if you write it in terms of cosines and sines, it's that guy. Okay, so we are being asked to verify this identity, that this fraction plus that fraction equals 1. And one of the strategies that we can use in these types of questions is, when you can't think of anything else to do, like, you know, common factors, whatever, is to turn everything into sines and cosines. So let's see what we get. A secant is 1 over a cosine. And a cosecant is 1 over a sine. And I'm going to take the left-hand side and I'm going to work with it. And when I'm finished, it should end up being 1, because the job of an identity is to prove that the left-hand side is the same thing as the right-hand side. So secant becomes this fraction, cosecant becomes that. What is cosine x divided by 1 over cosine x? Because that's essentially how you should look at this. What's cosine x divided by 1 over cosine x going to get you?
Cosine squared.
Cosine squared x.
Right, you probably don't need this line, but for those people who do, a fraction can be thought of as the top being divided by the bottom, which then becomes the cosine times the reciprocal. Remember the reciprocal rule there. Can you all see where the cos squared comes from? Right, you don't necessarily need those lines, but you're comfortable about why it's cos squared now. I'll just put little dots here. What's sine x over 1 minus sine x going to get me? Sine x on the top. Say again.
Sine squared.
Yeah. And have we seen sine squared plus cos squared before? Yeah, it's the same as cos squared plus sine squared. So it's 1. And we have proved or verified it, right? We've shown that the left-hand side does in fact equal 1. These questions are nice because you know what the answer is going to be, right? You know it's going to be 1, and you have to figure out how to make whatever this horrible mess it ends up being equal to it, in this case, 1. Got about 4 of these to do, I think 4 or 5, and then we're finished. This is question 12, or at least a version of it. No, scan to the wrong place, version of 13. 4 cos squared x, take away sine squared x, and we have to verify that it's the same thing as 5 cos squared x minus 1. Well, I look at this side and I look at that side, and I'm going to figure out, well, what we got here? Well, the thing that strikes me hopefully it strikes you. Doesn't this side have a sine squared and this side doesn't? Would you agree? This has a sine squared in it and this side doesn't. So I'm going to have to get rid of that sine squared. And if I look at my little list here, can't I change sine squared into 1 minus cos squared? Agreed? Sine squared can be written as 1 minus cos squared. So I'm going to leave that guy alone. Take away and replace the sine squared with 1 minus cos squared. And the brackets are important because you're taking away this guy and adding that guy. And then you can combine the cos squares together. We're finished. We proved it, haven't we? Isn't it 5 cos squared minus 1? Exactly what it should have been. Any questions about that one? Is that one okay?
What does that say at the very bottom of that in the
It says,
parentheses?
here it says proved it. I proved it. I don't need to put that down. I just put that for notes. This is 15. And it's such an ugly one. I'm going to start it on a new page. We are being asked, this is getting close to the ultimate, difficult version. A 1 plus tan squared over a 1 take away tan squared. And we're being asked to verify that this is the same thing as a 1 over cos squared take away a sine squared. And in my little list here, I'll tell you that the tan of x is the sine of x over the cosine of x. And one of our main strategies is when you get a question like this is to turn all the things into sines and cosines. Well, you should look for common factors and things like that first, but if there's nothing obvious, then you should do that. So it's going to be 1 take away tan squared. Well, that's basically sine, oops, I better turn them into u's, sine u over cosine u squared over 1 minus sine u over cosine u all squared. That becomes 1 plus sine squared u over cos squared u. And 1 take away sine squared u over cos squared u. So I've taken this and I now have everybody turned into variations of sines and cosines. I'm going to put a little bracket around this guy. And based on what the answer looks like, I don't think I'm very close to it right now. Would you agree there's a lot between getting from here to here, right? There's a lot happening. So I'm going to focus on one little problem at a time. I do not like fractions to have fractions in them, right? It's not a good thing to have. So I am going to change the way this fraction looks by multiplying by a special version of 1. And the special version of 1 I'm going to use is cos squared u over cos squared u. Can you see why I chose that special version of 1 to multiply this fraction by? Why it's cos squared and not sine or tangent or whatever, right? Can you see why I chose cos squared? Want to get rid of these two guys. So cos squared times 1 is cos squared u. Cos squared times this fraction, the cos squares cancel, and you got sine squared u. Cos squared times this guy is cos squared u. Cos squared times this fraction is negative sine squared u. There's a rule of algebra that says if you multiply a fraction by 1, you don't change the answer, you just change how it looks. So 1 can be anything. It can be 10 over 10, or in this case, cos squared u over cos squared u. Would you agree that's just 1? But the advantage is I now have that. Now, it's getting really close. Agreed? What's the last thing I need to show to get the answer? What's going on here that allows it to become this? Does anybody notice what the top is? What's cos squared u plus sine squared u equal to?
Oh, it's 1.
It's 1. Does it matter that it's cos squared plus sine squared or sine squared plus cos squared? Nope. Does it matter that it's x or u or w or t or theta? Nope. Doesn't it just matter that it's got a sine squared plus a cos squared is somebody and it's the same somebody? So you now have 1 on the top. And the guy on the bottom. Are we good? Right. Finished. You don't need that, but I put that in anyway. Our ultimate question, the last one. Get a fraction, cosecant x plus secant x all over tan x plus cotangent x. And we have to prove that it's the same thing as cos x plus sin x. That is our identity. Any suggestions for what to do in the next line?
Turn everything into sines and cosines.
Okay, so a cosecant is going to become 1 over sine. A secant is going to become a 1 over cosine. Tangent is sine x over cosine x, and a cotangent is cosine x over sine x. All of those things you'll find here. Ooh, I don't like the looks of this guy, but it's the right thing to do. I wish I'd give myself more room to put my equals in. There we go. I am going to multiply this ugly fraction, which has fractions in it, by a special version of 1 that's going to make all those fractions go away. It's quite an ugly version of 1, right? So the top and bottom has to be the same thing. What ugly version of 1 is going to fix this? There's the guy we used a moment ago. What ugly version of 1 is going to get rid of all these little pieces of fractions? There is a clue in what I'm pointing at. Go for it. If you're wrong, you're wrong.
Sine over cosine.
Okay. Sine x, cosine x. Let's see what happens. I might write this down in separate pieces of paper just to show you the individual steps. So I'm going to multiply every single one of these guys by a sine x times cosine x. So if you take the first one, which is this guy, and you multiply him by a sine x, cosine x, the sines cancel and all you're left with is a cosine of x. You happy with that? If you take the next fraction, which is 1 over cosine x, and you multiply it by a sine x, cosine x, don't the cosines cancel and you're left with a sine x. If you take this one, which is sine x over cosine x, and you multiply it by a sine x, cosine x, the cosines cancel and a sine times itself is sine squared x. And if you take the last one, which is cosine x over sine x, and you multiply that by a sine x, cosine x, the sines cancel, and a cosine times another cosine gets me a cosine x. Would you agree that's a big improvement on the fraction that it was a minute ago? Would you agree that's much nicer? Do you see anything top or bottom that can be simplified? Top?
The bottom
Well,
can be turned into 1.
Right. You might not need this line, but I'm putting it down for notes. Isn't a fraction over 1 not really a fraction anymore? Hey, haven't we proved it? We proved it.
So why did we pick sine x, cosine x to multiply it?
Right. If you look at the fractions, the guys that are causing the problem is a sine x on the bottom and a cos x on the bottom. So by multiplying by sine x, cosine x, I know I'm going to get rid of these two. In the previous question that we had, do you see that the only guy that was causing trouble was a cos squared? Right, the guys in the bottom are the guys that cause trouble. So cos squared has to go. So how do I get rid of it? Cos squared, cos squared. How do you get rid of a sine and a cosine? Sine x, cos x, sine x, cos x. So that's how you pick it. You look at what's on the bottom and you get rid of it by the special version of one, which is made up of that same guy. Let's pretend I had a question where I had right, suppose we ended up a fraction that's got a bit of this and a bit of that. If I wanted to get rid of these two fractions, I'm going to use that special version of one trick, right? Well, I'd look at the top and say, well, cosine x has to go away, so I'm definitely going to use a cosine x. And then I look at the bottom and say, well, that's not going to help this guy, but the sine x will. And in this case, then you must do the same at both the top and bottom. I'll do this quick, but if I multiplied this through, I would get a sine x plus a sine squared x cos x, and the bottom would be a cosine x plus a sine x cos squared x. And that might be what they asked us to prove it was equal to. But the trick to doing this kind of situation where you have a fraction with fractions in it is to get rid of them, right? And use the special version of one trick. That's how we do that. Does that help? Why I chose what I chose, it wasn't just random.
Yes, thank you.
Okay. So we're finished unless there's any more questions from that section. Okay, so you give me a few seconds to open up the next window. That goes away, don't want you. That window goes away. Okay. Have we picked on the French lately or at all?
Not very much.
Okay. I might have told you this one. How many Frenchmen does it take to defend Paris? You meant to say, I don't know.
I don't know. How many Frenchmen does it take to defend Paris?
Nobody knows. It's never happened yet. Okay. Did you hear about the new French tank? It's got 1 forward gear and 10 reverse. Okay, let's pick on the Germans then for the last one. I need a little break just to give myself a chance to get this done as well. Did you hear the latest news that Hitler was actually Irish? They discovered his original birth certificate and he was born in Ireland. And his name wasn't even Hitler. His original name was Richard Potato. This is his original name. But when he moved to Germany, he changed it to Dictator. Oh, Harvin liked that joke. I'll take it wherever I can get them, right?
That was actually pretty good. I kind of like that.
Well, jokes are kind of personal. Some people like particular jokes and others they don't find so funny. So we are going to start today with what is called, let's get its right name, addition and subtraction formula. So it's in 7.2. Just writing the heading down. There we go. And so it's basically, you're going to have a formula that allows you to take the sine, the cosine, or the tangent of two things added or subtracted and replace them by other things. So there's a lot of them. So here we go. The sine of A add B is the sine of A cosine of B plus the sine of B cosine of A. So if you want to do the sine of 30 degrees plus 45 degrees, then A goes here and B goes here. I'll give that a number. That's number one. Number two is you might want to subtract them. That's why it's called addition and or subtraction formula. So if you want to find the sine of something, take away something, like, I know 60 take away 15, the answer is going to be the sine of A cosine of B, take away the sine of B cosine of A. So far, so good. Now we'll do the cosines. You have the cosine of A plus B, and that's going to be cosine A times cosine B, take away sine of A, sine of B. And the cosine of A take away B is going to be cosine A cosine B plus sine of A sine of B. Do you see that they're not random? Aren't these two closely connected? Aren't they the same things, one way a plus and the other minus? And for the two cosine ones, aren't they very similar? One's a plus and one's a minus. I mean, it's really good if you can memorize these, but at least we have them written down somewhere so that when you're on this section, you'll have the addition or subtraction formulas in front of you. I promised you, well, I didn't know if I mentioned 6, but there are 6 of them. And so we have the tan of A plus B, and we have the tan of A take away B. And this guy is the tan of A plus the tan of B over 1 take away tan of A tan of B. And I didn't need enough room for this one, so I moved it down a little bit. What do you think the formula for tan of A minus B is going to be using this as your template?
Would it be the same fraction except the top would be like minus and the bottom would be plus?
You nailed it. Does that make sense? It'll be symmetry, whatever you want to call it. So we have a lot of addition and subtraction formulas, which essentially allow us to find the sines and cosines of things added or things subtracted. And you might think, well, how can that be of any great use? Well, one of the things we love in mathematics is exact values of things, right? We don't want to know that the sine of 45 degrees is 0.707 and, you know, infinite number of decimals. We don't like answers. Don't we like the sine of 45 degrees to be root 2 over 2? And doesn't the unit circle and provide us with those kind of things, right? So we're going to be using the unit circle today, but we're going to use it to find things like this. We're going to be asked to find the exact value of 75 degrees. That's an example. Now, you can only use angles in your unit circle. So let me put the angles that are typical in the unit circle, right? Imagine that's my unit circle. In degrees, you've got 30 degrees, you've got 45 degrees, you've got 60 degrees, you've got 90 degrees, you've got 120 degrees, then you've got 135 degrees, then you've got 150 degrees, and so on and so forth. I can't write them all down, there's lots of them, but do you notice that they're only, if you go around your unit circle, wouldn't you be able to find these guys, right? There are only certain ones there. Of course, if you're going to do it in radians, it's pi upon 6, pi upon 4, pi upon 3, pi upon 2. What's that? What is that?
2 pi over 3.
Thank you. Try to get them in order here. This one is 3/4 pi. What's this last one? That's going to be 5/6 pi, right? Gotcha. Well, you're going to have your unit circle there anyway, but there's a kind of smattering of what could happen. So back to the question. I need to write the cosine down as 2 things added or 2 things subtracted that come to 75, but they must come from the unit circle, right? They have to be these numbers, right? Or, you know, all the other ones I haven't written. Can you think of, and try to keep small, don't make your life difficult. Can you think of any 2 angles that add and subtract to give you 75? So think of 2 numbers that add or subtract to give you 75. It's kind of
30
puzzle.
and 45.
That's what comes to my brain. Try to think if there's any others. 135 and 60 might work. Yeah, wouldn't 135 take away 60, also giving you 75? Would you agree? 135 take away 60? Yeah. So there are very often there's more than one way to do it, but pick the simple numbers. Now, once you've picked that, I want you to think of this as a plus b. And the cosine of a plus b is the cosine of a, cosine of b, take away the sine of a times the sine of b. In this case, it's going to be the cosine of 30 degrees times the cosine of 45 degrees, take away the sine of 30 degrees times the sine of 45 degrees. And I'm rapidly hunting for my unit circle, but I don't think I've got it anymore. Probably threw it away by now. Oh, I take it back. I'm glad I got lucky. Here is my unit circle. Aren't every single one of these on the unit circle? So I'm going to be able to use exact values. Right, now if I want the cosine of 30, here's my 30 degrees. Is the cosine the root 3 over 2, or is the cosine of 30 degrees a half? Which one is it?
A half. Root 3 over 2.
Okay. Easy for the cosine of 45, because it really doesn't matter because of the same number, so root 2 over 2. Take away the sine of 30 degrees. What's the sine of 30 degrees? X or Y coordinate, what's the sine of 30 degrees?
Why?
It's the Y coordinate, which is a half, times the sine of 45, which is root 2 over 2. So far, so good. So each one of these four things, you can get them from an X or a Y coordinate, right? In here. Going to tidy it up a little bit. Root 3 times root 2 can become root 6, and 2 times 2 is 4. 1 times root 2 is root 2, and 2 times 2 is 4. Since they share a common fraction of 4, a common denominator, there is your answer. We now know the exact value of the cosine of 75 degrees. Right, so whenever you get a question, find the exact value of, you know you're going to probably be doing something like this to do that. I guess I should check it. So I'll make sure I'm in degrees, which I now am. And I'm going to do the cosine of 75, and on my calculator, I get that ugly decimal. I'm now going to do bracket, the square root of 6, take away the square root of 2, and then divide everything by 4. And I better see the same ugly decimal. Right, have I proved to you that it actually works, doesn't it? The exact value of the cosine of 75. That means we can now add to the angles we know exact values for, right? Okay. Next one. We want to find the exact value for the sine of 255 degrees. Okay, I'm going to keep this guy here because he's better than the one that's underneath. Two things added or two things subtracted that come to 255. I've already found one. Hopefully you can as well. Two things added or two things subtracted that get you 255.
135 plus 120.
So I hear 135 plus how much again?
120.
And that adds up to, yep. And that's fine, nothing wrong with that answer. In fact, I'll probably use it, but let's go hunting for others. Can anybody?
245.
I heard the 45, but I kind of missed the first one. Was it 210?
Yeah.
Yeah, would you agree that adds up to 255? Right. We could use that one. Oh, by the way, you get the exact answer. So it's not that this answer is different from that. They're all they end up being the same answer. Can anybody find a subtraction? I'm not saying it's possible. I'm just asking. Can you find something, take away something that gets you 255? I found one.
345.
300. Take away 45. Nailed it, right? If we kept on looking, couldn't we probably find a couple more? I'm not going to. Isn't the job just to find one? Any one will do. And as long as you find one, you're going to get the right answer. Since I've got 3 in front of me, do you want me to do the top one, the middle one, or the bottom one? Which one do you want me to try? Can I pick then? I'm picking the bottom one because it's got a subtraction, and I want to do a subtraction one. So the sine of 300 degrees take away 45 degrees. And I'm going to think of that as an A take away a B. And the formula is the sine of A cosine of B take away sine of B cosine of A. You comfortable with that formula? Right, now I'll put in all the pieces. What we're going to do, a sine of A becomes the sine of 300 degrees multiplied by the cosine of 45 degrees. Take away the sine of 45 degrees times the cosine of 300 degrees. Right, the sine of 300 is this one here. And the sine is the y coordinate, so it's negative root 3 upon 2. The cosine of 45 is here, and the cosine is the x coordinate, so it's root 2 over 2. Take away the sine of 45 is also root 2 over 2, and there's 300, and the cosine of 300 is 1/2. And if you multiply these together, you get negative root 6 over 4. And if you multiply these together, you get that guy, and they share a common denominator, and there is our answer. The sine of 255 degrees. Are you getting comfortable with this method? Find 2 guys that add or subtract to get you, in this case, 255. Once you've figured out what it is, isn't it going to be one of these 6 guys? And then all the numbers come from your unit circle, right? All the fractions will come from here. Right, let's do a tan then. Oh, any questions? Okay, let's do a tan now. And after that, we'll do radians. Radians are harder. Tan of 165 degrees. Two things added or subtracted that get you a tan of 165. I've got one.
135 plus 30.
Okay, that'll work. I'll call this A, call this B, great. And the tan of A plus B is this top formula. So it's going to be tan of A plus the tan of B, and 1 take away tan of A tan B. So it's going to be the tangent of 135 degrees plus the tangent of 30 degrees. And it's going to be 1 take away those two things multiplied. Okay, if we find 135 degrees, it's this one, right? I should do this down here. The tan of 135 degrees is the y coordinate divided by the x coordinate. The y coordinate is √2/2, and the x coordinate is -2/2. Can you trust me that you get -1 when you're finished? You okay with that? The tan of 135 is -1. Okay. Let's do tan of 30, the other term that's in this one. It's going to be the y coordinate divided by the x. And the y coordinate is 1/2. And the x coordinate is √3/2. And the 2's cancel, so you get 1/√3. And then when you make that look pretty, you get √3/3. Okay, so that's what that's going to be. So we get the tan of 135, which is -1, add this guy, all over 1 take away -1 times √3/3. And I now have that guy. This situation happened earlier today. You know, you don't like fractions with fractions in it, right? I don't like this fraction here on this one here, but I'm going to get rid of it. What special version of 1 will get rid of these 3's here? What special version of 1 makes this 3 and this 3 go away?
Three over three.
Yeah. It's as easy as that. 3/3. Correct. Now, multiply the top guy, you get -3. This times this gets you plus √3. On the bottom, this is 3. And you get plus √3. And there's your answer. The exact value for the tan of 165 degrees is that. So we've done what? A sine, a cosine, and a tan. You feel good about the process? Two things that add or subtract to give you 165. It doesn't matter which two, they all end up being that when you're finished. As long as you pick from the unit circle, of course. No, actually, I was going to do radians, but I've changed my mind. I'm going to keep to the degrees all day today. And then tomorrow, we'll do the same kind of things, but with radians. That way we're focusing on one topic at a time. This is a different type of question. This is question 5. And you are being given a calculation. The cosine of 50, the cosine of 40. Take away the sine of 50, the sine of 40. And we're being asked to find out by using one of these formulas what that is simplified to, and then get the answer. So one of these guys here looks like this guy. Is it a sine A plus B or A minus B? Is it the cosine A plus B, A minus B? It's definitely not those two. Which one of them has this shape to it? It looks like this guy.
Cosine A plus B.
So let's see what she said. And she's saying cosine, cosine, take away sine and sine. Would you agree that's the only one that works? Now, in that case then, shouldn't this be the cosine of something plus something, right? Like an A plus B. Who is A and who is B in this question? What numbers is A? What number is B?
Wouldn't 50 be A and 40 be B?
I agree. And so won't this become the cosine of A plus B? Oh, wait a minute. Isn't that just the cosine of 90? And if I go to my unit circle, what angle has a x coordinate of 0 and a cosine of 90 is? There, 0. And so that's the finish. Let's see if we can find any more of those guys. Oh, well, I spoke too soon. I thought there was more degrees than that, but that's fine. I'll do one more of these and then we'll move on to radians. That's good. We've still got 10 minutes after this. Suppose I gave you this one. It's not really question 6, it's my version of question 6. And I'm going to do the tan of 30 degrees plus the tan of 60 degrees over 1 take away the tan of 30 degrees times the tangent of 60 degrees. Which one of these 6 guys looks like this fella?
Number 5.
You agree? That one. And in this case, then, won't A be 30 and B be 60? And it's a tan of A plus B.
So wouldn't it just be 10
Keep
pi
talking.
B,
Yeah,
which is equal to 0? Sorry, yeah, undefined technically.
undefined. But that's okay. That's what the answer is. It's undefined. So if they give you a calculation made up of sines and cosines or tans, don't you just go hunting for which one it belongs to? Figure out who the A and B is and plug it in. And the answer that you get, I guess I should put this in, is going to be a single number that you can get from your unit circle. And it'll be 0 or 1 or pi or whatever it is. Now, the next bunch of questions are essentially the same questions that I've just done, but we are going to have to do it with, where's my guy? Right. We're going to have to do it with radians. Okay, so suppose I ask you to find the exact value of 5/12 pi. And we have to find 2 guys added or 2 guys subtracted, get you 5/12. And the problem with this is it's much more difficult, isn't it, to add and subtract fractions and figure out which one is 5/12. Would you agree? It's just hard to do. So here's a little cheat for you. We can turn that into degrees. Won't that allow us to figure out what the number is in degrees? And it's been a while since you did it, but how do you turn 5/12 pi into degrees? What do you do with 5/12 pi?
Divide by 180.
The 180 is in the answer, but not the way you said it.
Multiply by 180 and divide by pi.
Yeah, you were going to do it the other way around. So you were darn close, right? Now that ends up being what, 5/12 of 180? I should be able to do that. I hope I picked one that actually works. That would be a good idea. Oh, good. And guess what? It's 75 degrees. So isn't this question really just the cosine is 75 degrees? Would you agree that's a much easier one to deal with? Because it's the same question, right? Two guys that add up then to give you some. God, I'm getting deja vu. Have we done that one? Okay. Then what would the cosine be just to complete this? What would the two numbers be?
B 30 plus 45.
And if you wanted to, which you probably should, couldn't you then just convert them back into radians and now you've got the answer the way it's meant to be written? So you turned it into degrees so that you could get these numbers, and then those numbers. And then can't you do the usual sine of pi upon 4, cosine of pi upon 6, calculate it, and it'd be exactly what it was earlier. Does that help in those questions where it's radians rather than degrees? Now here's another problem that can happen. I want to find the exact value of negative anything. I've just picked 75 because that seems to be the number that's floating around right now. We need to deal with a unit circle, right? Now, I could probably get away with just picking one number and taking away a bigger number and getting that, but that tends to be quite difficult. So what I'm going to do here is I'm going to find out what it's the same as. Well, if you take 360 and you subtract 75, it's the same as 285 degrees. My brain finds it easier to add and subtract things that have a positive answer than trying to add and subtract things that have a negative answer. But you get it's just easy in your brain. It's still a big number, but there are always going to be some choices. Any suggestions? Two numbers that add or subtract to give you 285.
135 minus
240
16.
plus 45.
Sorry, never mind.
Right, that definitely works. Did you have a different idea, Jason? That's correct, that'll work. Did you have the same
I
one?
was thinking we could do 60 minus 135 to get negative 75.
So you were going to go 60, take away, how much again?
135.
135. And that would work, because won't that just be an A minus B, and this will be an A plus B? So if you go the way Jason did, you see he didn't bother turning it into this. He just figured out something that would work directly. I mean, that works totally fine. It really doesn't matter. This answer and this answer are going to be the same. Which one do you want me to do? The top, the one in the middle, or the one in the bottom? Which calculation do you want me to do?
Can we do the top one?
So this one here? Yeah, okay. So it's going to be the cosine of 240 degrees plus 45 degrees. Have you noticed that 45 degrees seems to be there in almost every question somewhere? Right, so that's going to be A and that's going to be B. So the formula I'm going to use is the cosine of A, cosine of B, take away the sine of A, sine of B, right? And that's going to be the cosine of 240 degrees times the cosine of 45 degrees minus the sine of 240 degrees times the cosine. Can you pretend that says 45 because it's so small? Right, cosine of 240. Here's 240. The x coordinate is the cosine, so this guy here is negative a half. Times cosine of 45 is this one. That's root 2 upon 2. Take away sine of 240, back to 240. The sine is negative root 3 over 2, and the cosine is root 2 over 2. This times this gets me negative root 2 over 4. Two negatives make a plus square root of 6 over 4. Since they share a common denominator, I think it makes sense to put the square root of 6 first and take away the square root of 2.
I have a quick question. Why did you write
Yes.
times the cosine of 40? You did cosine 240 times cosine 45 minus sine 240 times cosine.
Oh, thankfully it's the same answer, but
Yeah.
it should have been sine. Let's try this one. This is some radians again. Tan a pi over 24 plus the tan a pi over 8 over 1, take away the tan of pi over 24 times the tan a pi over 8. One of these 6 guys has that shape to it, right? One of these 6. I think it's pretty obvious it's 5 or 6. Right? It's one of these 2. Which one is it?
Be 5.
Hasn't it got the something plus something on the top and 1 minus on the bottom? Right, it's got this look to it. So in this case, that's A, right? And this guy here is B. And this is the tan of A plus B. And this is the tan of pi over 24 plus pi over 8. Well, okay, let me show you a trick. Suppose you're adding ugly fractions of pi, right? Pi over 24 add pi upon 8. Forget about the pi for a minute and just do 1/24 plus 1/8. And then go math button, choice number 1, and the answer is 1/6. So you are going to get 1/6 pi. You see how we just let the calculator do all the hard stuff. And back to my unit circle. 1/6 is this guy, right? And the tangent is the y coordinate over the x. It's 1/2 over root 3 upon 2. The 2's cancel. And then you rationalize the denominator and you got your answer. Okay, you put your last name down for attendance. I will be giving you or sending you sometime late this evening, because it'll take about 3 or 4 hours to do it. Your results, that's your midterm report. Not only will it have your test scores on it, it will also have everything else, so you'll know exactly where your grade is up to week 5. So it's like